right, so we're going to get started with kind of the second half of chapter 10 now, and we're going to first go over something called the law of sines. So we're still going to be using a little bit of that trig that we talked about in the first part of chapter 10, but this law of sines, and we'll also in the future talk about something called law of cosines, this allows us to do trig on any type of triangle. So prior to this, we've only been working with right triangles. So all of them had that 90-degree angle in them. We talked about how to set up sine, cosine, and tangent, how to use those special right triangles, the 45, 45, 90, 30, 60, 90, and how to set them up to solve for missing angles and missing sides. Now we're going to get into if we have any other type of triangle. So whether all the angles are acute or all, if you got one that's obtuse, and the other two are acute, or if you still have a right triangle, we can use these two laws on them to help us figure out missing measures. So, law of sines basically goes over how if you are looking at a triangle, there's some ratios between angles and the sides across from that are always going to be equal to each other. The first thing I want to talk about is how we can actually find the area of any triangle using one of these three formulas. Okay, so I've got kind of a couple of them written down here, and they're different only with like what angle you're looking at. So what kind of side, which part of the triangle you're looking or starting at, and then you're basing everything off of that place. So for example, this first one, if I did a half of the sides B and C. So those are the lowercase letters. And then I took it times sine of A. So basically to find area, you have to pick an angle. So if I'm picking angle A, I don't want to use the side that's across from it. So I want to use the two sides that are on either side of that angle. They do the same thing for if instead of using A, let's say I used B. Okay, let's say I did the middle one instead. So if I'm doing angle B, then I would use C and I would use A for my two sides. And then finally you can do the same thing with angle C. So if I'm looking at angle C down here, I'm using sides A and sides B to set up my equation. Now all the equations look the same. A half times those two sides times the sine of the angle that you're basing it off of. It just depends on what pieces from the triangle do you pull when you're trying to find area based on what they give you. Okay, so for example, if we look at this one, we want to figure out what the area is of this triangle. We want to round it to the nearest 10. They're giving me 86 degrees here, and they give me 8 and 12. And those are on either side of that 86 degrees. So I should be able to use one of my formulas from up above. Now it doesn't really matter if I do the one for A, for B, or for C, because it's not labeled here. So I could call it A if I wanted to, or B, or C. To set this up, I'm just going to do 1/2 of those two sides, so 8 and 12, so 8 times 12, and then times the sine of 86. So you're going to need a calculator for this, because you're going to have to be using that sine button. And you should, if you want to, be able to just write this all out in your calculator, type it all in as one big sentence here, and it should calculate that for you, because you're just doing a big multiplication problem. So you can do 1/2, or you could do 0.5 if you wanted to, if you want to just use a decimal, and then times 8 times 12, and then times the sine of 86. Now if your calculator is putting parentheses in, I would close the parentheses anytime your calculator throws one at you, just to get in that habit, because later when we start moving things around with using law of sines and law of cosines, it's helpful to have those things closed off because it just helps your calculator read it better for you. Okay, so I typed all that in, I'm hitting enter, and if I round, because I'm getting 47.88307441, I'm going to round this to 47.9 because they want it to the nearest tenth. Now we're talking about area here, so area would be whatever the units are squared. Now, I don't know what this is measured in, whether it's centimeters, feet, inches, I have no idea. So if I don't know the label, we use the letter U for units, whatever the triangle is being measured in, and then it's going to be squared. So U squared for units squared. So you guys try number 2. All right, so here's what you should have typed in. And then if you go and round it, because I'm getting 15.89757793, I'm rounding it to the nearest tenth here. So I'm going to round that to 15.9. And then again, it should be u squared, because I don't know what this is being measured in. All right, so that's a way to find area for any type of triangle. Okay, now you've also probably talked about area of triangles as just like half times base times height. But that only works if you have a height that's got that 90-degree angle in it. And that wasn't given to me for either of those triangles, which is why this formula works. Okay, so now what we're going to do is kind of branch off of this and get into that law of sines. And like I said, this works for any type of triangle. So right triangles or what we call oblique triangles. Oblique triangles are anything that's non-right. So it doesn't have a 90-degree angle in it. So law of sines is useful when you're trying to figure out like missing sides or missing angles for non-right triangles. You don't have to just use sine, cosine, tangent like our SOHCAHTOA, those types of rules that we talked about in the past. We can use law of sines, which the main thing to kind of think of is down here in this box, right here where I'm highlighting. You're going to set up some type of proportion that looks like this. You're going to do sine of an angle over the side opposite of that angle. And you're going to set that equal to another sine of an angle over the opposite side of that angle. So you're going to be looking at 2 different angles in this problem and 2 different sides. The only thing is that this one we do want to keep the things that are across each other together. So in my picture here, like angle A, across from that is little a. So I want to keep those together. So angle A and side A are going to go together. Same then with angle B and side B. Those are across each other, so they're going to be connected. And angle C, side C are also going to be connected. Now we could set up all 3 if we wanted to and use them to help us figure out anything that's missing. But most of the time, you're only going to set up 2. You're going to set up a proportion, and then we're going to use our cross multiplication method to help us solve it. Okay, so let's take a look at an example here. They want us to solve this triangle. Okay, we have seen problems like this before where it says solve the triangle means that they want anything that's missing. We have to figure out what it's equal to. Round angles to the nearest whole number and sides to the nearest tenth. Okay, so I'm looking at this triangle down here. I see a side x, so I know I'm going to have to find that. I'm going to go ahead and call this side over here y. They don't have it labeled, so I'm going to go ahead and give it a letter. And then we are missing angle C, so we'll have to find that one too. So if you guys remember when we did these in the past, I like to write over here, like in a separate area and box it up, what exactly I'm missing so that I don't forget about anything. So I need 2 sides, x and y, and I need angle C. Once I have those 3 things figured out, I'm done with this problem. Now, I think finding the angle is going to be the easiest thing to do. Okay? Do you guys remember how much angles in a triangle have to add up to? 180. And I have 2 of them. So to find the third, I'm going to subtract those from 180. So I'm going to start by doing 180 and subtract that 78 plus 60. And so that leaves me with 42. Okay, so that's angle C. Okay, so that was easy enough to find that. Now what I'm going to do is start using my law of sines to help me figure out what x and y should be equal to. So let's start with x. So angle x, if I think about what angle is it, or side x, what angle is side x across from? Well, it's across from this 60 degrees. So if I'm setting it up using my law of sines, I'm going to do the sine of 60 degrees. So sine of 60 over that side across from it, which is x. So it looks like a fraction. Now I'm going to set this equal to another fraction, and I'm going to set another angle on top and the side across from it on the bottom. Now in this case, I would use the 78 and the 8 only because I don't want to have multiple variables in my problem. I don't want to have both x and y because then I'm going to get stuck because I can't solve it if I don't know what one of them are equal to. So I'm going to use the two sides and the side and the angle that I know. So those two pieces of information that they give me. So we set that up, sine of 78 over 8. At this point, we're going to cross multiply. Okay, so this is also, like in the past, I've heard students call it the butterfly method. Okay, so I'm going to take that sine of 60 times 8 and sine of 78 times x. We're going to cross multiply here. So now it's going to say x times the sine of 78 is equal to 8 times the sine of 60. Now my goal is to figure out what x is equal to, because that's my variable in this problem. Right now on the left side I have x times the sine of 78. So I'm going to divide both sides by the sine of 78 in order to get x by itself. So I've got 8 times the sine of 60 on top, and it's being divided by the sine of 78 on the bottom. Okay, you're going to need a calculator to do the rest of this here. And don't try to do this all in one big step because this is where mistakes can start to happen. I would do the top first, so I would take 8 times sine of 60, hit enter, you're going to get a decimal, and then I would just divide that, so I would just hit divide and type in sine of 78. Okay, you're probably still going to have a decimal. It's really rare for these to come out as whole numbers because you're dealing with not a perfect triangle here with perfect sides that are going to work in like Pythagorean theorem or anything like that. They're going to have decimals involved. Okay, so if I round, because I'm getting 7.08, I'm rounding it to the nearest tenth, so that's going to be 7.1. Okay, so there's my x value, so I'm going to fill that in my box up here. Now I'm going to do a similar setup to help me solve for y. Okay, so kind of coming back here to my triangle, I need to figure out y's value. So remember, y was across from that 42 degrees that we found at the very start of the problem. So I'm going to do sine of 42 over my y. And I'm going to still use the 78 and the 8. Just because that was given to me. They're both whole numbers. I could use the 60 and the 7.1 if the decimal doesn't bother you. You can use whatever side you want at this point because y is the only thing that's missing now. But I'm just going to set this up just like I did for x. I'm just switching it for y now, so that changes that first angle. The process looks the same. We're going to cross multiply. So I have y times the sine of 78 equal to 8 times the sine of 42. Then I have to divide by sine of 78. Okay, so just like we did for x, For y, I have to take 8 times the sine of 42. So I would do that first. And then divide by the sine of 78. So really everything about this problem is the same, except instead of sine of 60, I have sine of 42, because I'm looking at a different angle now. Okay? So when I round this one, I get 5.5 for my y value. Okay, so I found all 3 of my missing pieces. I found my x, I found my y, and I found my angle. All right, why don't you guys take a look at number 2 here. I'm going to go ahead and label the side connecting P and Q together. They don't have a letter there. I notice that one side is P, and that's because it's across from angle P. So if we want to keep it consistent, let's just call this little r, because that would be across from angle R. So for this problem, I am missing those sides R and P, and I'm missing angle Q. Okay, I'm going to give you guys some time. I want you to try to work through this problem. Okay, so the first thing I did is found the measurement of that missing angle Q by subtracting 17 and 29 from the 180, and I got 134. So I'm going to use that to help me set up my law of sines for both side P and side R. So if I start with side P, I would have done the sine of that 17 degrees over side P, so lowercase b, P, and then set that equal to the sine, and I'm going to use that 134 over 12. Okay, and then we would cross multiply here. So to finish this up, you end up taking 12 times the sine of 17, and then you end up having to divide that by the sine of 134 to get P by itself. So when I do all of that and I rounded, I got 4.9 for my P. I'm going to do something similar for the letter R. So I'm going to do sine of 29 over R, and then sine of 134 over 12. And then we cross multiply. So for this one, for R, I took 12 times the sine of 29, and I divide that by the sine of 134. So again, it looks a lot like the first one did. I'm just changing what angle I'm using. Instead of doing sine of 17, I'm doing sine of 29. And so for R, I get 8.1. There is one more on this page here. And if you would like to try it on your own and have me check it for you, I can do that. It's exactly like those last two that we just did, so it would be similar setup. You would want to find that angle R first, and then use that to help you set up your sine proportions to help you figure out those missing sides X, and then you can call that other side whatever you would like.